Huh?
Yes, sir.
Yes, sir.
तो पूरे भेज दे, फिर क्या हो जाएगी, पूरा लेकर भी तो आ जाएगी. So you know most of the thing, because in case of register we have to consider different type of Pratigya, am I audible?
Yes, sir.
Virender, am I audible? Virender, am I audible?
Yes, sir.
Huh.
Yes, sir.
So normal series combination and parallel combination, you will not face issue because it's very easy. Key, if you have multiple register in series, current will be same. That is the important point. Current will be same in each register, but potential will be different.
सर
Yes.
सर कलर कोड तो नहीं है ना सिलेबस
हाँ,
में?
इसलिए हम नहीं कर रहे हैं. कलर कोड नहीं है, आया भी नहीं है अभी रिसेंट टाइम में, है ना. So same current will be following. Why? Because example, if this battery is responsible for movement of four charge particle, same four charge particle will pass through R1, R2 and R3 resistor. Correct? So current will be same. That's why you have same current. But if resistance value is different, then potential could be different. What will be the total potential? Total potential will be the addition of all the resistors. Total potential will be the addition of all the resistors. You know, the V1 will be IR1, IR2, IR3. I is common. V will be equal to R equivalent. So I will be common, cancel out, and your in series it will be simple addition. And remember, you have to note down. I will check your notes especially for this point. E opposite to capacitor. Opposite to the capacitor. Opposite to the capacitor. Okay, this is important. Or even this combination of resistor, you can write here opposite to capacitor. So you don't need to remember capacitor. Just focus on one and another will be opposite. Right? Another will be opposite. So what will you do? First, you know R1, R2, R3. Current will be same. You will use potential addition formula, put the value and you will get answer. You put the value, you will get answer. These points are important. In case of series, current remains same. Correct. Current in the circuit is independent of the relative position of the various resistor. It means doesn't matter where you keep the resistor. If you keep one resistor here, then second resistor here, third resistor here, fourth resistor here, fifth this, and then sixth this. It does not depend upon the position of the resistor. If you have a given value of resistance, then current will be according to the overall value. Does not depend upon the position. Understood, guys? Voltage across any resistor will depend upon the resistance of the given resistor. So if resistance is more, then voltage will be more. That is important for your question. So V directly proportional to R. More resistance, more voltage. Total resistance addition. But remember, when you are adding total resistance, you have to add internal resistance also. You have to add internal resistance also. And final value, total resistance in series will be great maximum than any of the resistance. This is the basic thing, basic rule. If you take R1 1, R2 2, R3 3, total resistance will be 6, which is greater than any of the resistors. Tell me, guys, any doubt in the series combination? Anybody?
No, sir.
No, sir.
Parallel just opposite to this. And one rule you have to focus on, in case of parallel, potential difference remains same across each. Potential is same, but current could be different or same. It depend upon the amount of resistor. Okay. So potential, if example here, this potential is E, then it will be E, it will be E, it will be E, like that. If it is V, then everywhere it will be V. Okay. Current, whatever current you have here will divide into three parts, I1, I2, I3. And all three will combine, again it will become I. Okay. So in this, if you calculate total current addition of all. Barinder, in case of series, what value you will add? Like how we are adding I1, I2, I3 is equal to I. Potential, potential, potential. Okay. Same method, V is equal to IR, Ohm's law. You keep I1, I2 and I3 value, and then you can get answer. Okay. You can get answer. So value you will get in this way. In this case, if you try to calculate overall resistance, parallel total value, it will be less than the minimum value. Example, if you take R1 1, R2 2, R3 3, and you want to calculate total resistance, it will be less than 1. Okay, because reciprocal value, correct? So it will be smaller than the smallest value, smaller than smallest value. So what are the rule? Resistance remain, potential difference remains same. Current inversely proportional to the resistance. Very, very, very important. Current inversely proportional to the resistance. Here, potential directly proportional in this case. Potential directly proportional to the resistance. More resistance, more potential. Here, more resistance, less current. You can compare based on this law. Total current, total addition, reciprocal added, and resistance value will be less than the smallest value. Okay. Any doubt, guys? This point is not given resistance value, but I told you here. You can write this point. I will check this point also. I will check only the most important point. If final resistance value will be less than the minimum value. Final resistance value will be less than the minimum potential value. Done? Got it? Yes or no, guys?
Yes, sir.
Cell. Same cell is given in your electrochemical cell, electrolytic cell, chemistry cell. So it convert chemical energy into electrical energy. Basically, you are talking about galvanic cell, right? It happen in the galvanic cell, or electrochemical cell, or voltaic cell. Hmm. So here cell is the source of the constant EMF, not constant current. Remember, current can vary, but your EMF will remain same. Electromotive force. The force it is exerting will remain same, not current. Okay. This is the symbol of the cell. Cell. So what is EMF? It is the potential difference when it is not supplying current. It means maximum potential difference. This point is important. Potential difference across the terminal when it is not passing current. So then what is potential difference? It is the same voltage across the terminal, but in this case, when it is supplying current. So potential difference term you use when there is current. Without current, EMF. Example, if you get a battery from the market, any battery, like this is the battery. Here you have two. But whatever was the maximum value of this battery, like it was 2 volt. So it was its EMF. But out of 2 volt, when you connect it with your device, the maximum current it provide is due to the 1.8 volt. So in reality, only 1.8 volt is acting. Remaining zero point 0.2 is useless. So it's like theoretical value, 2 volt maximum value. In reality, what potential is working or voltage is working is potential difference. Understood, guys? Any doubt? If you see on any of your device, you will see key voltage is given in every situation, even in your mobile, any electrical gadget, you will see this volt, how many volt it is. So EMF is the maximum potential difference. You can see in the simplest term. Potential difference formula, V is equal to IR. You know this. V is equal to IR. Internal resistance. So you know internal resistance is because of the example here you have electrolyte. Due to this electrolyte, there will be some resistance created. This will be known as internal resistance of the cell. And it depend upon the distance. More distance, more resistance. You know, same rule of the resistance. Inversely depend upon the area and it depend upon the nature of material, concentration of the solution. It also inversely depend upon the temperature. It means if you increase temperature, resistance will decrease. Correct? If you increase temperature, resistance will decrease. So using this method, you can say your internal resistance will directly depend upon the distance between the plate, concentration of the solution, area, and temperature. These are the four factors that affect the internal resistance of the system. Okay, internal resistance. Internal resistance. Next, if you have closed circuit, what will happen? EMF will be equal to the all the potential. EMF will be equal to the all the potential. How? Your total voltage is EMF equal to what is the potential across big R? Current is I, resistance is R. What is the potential across small r? Current is I, small r. Why this? Because your internal resistance and external resistor both are in series. Both are in series. That's why you are adding their potential and you are getting maximum value. Okay. Any doubt, guys? I is common. If you want to calculate I, you can get this value. You can get this value. Potential difference will be equal to IR. Yes, remember one thing. Your potential difference will be decided by the external resistance, not internal resistance. It will be decided by external resistor, not internal. It will depend upon the external resistor, not internal. External, not internal. Next, what will be the potential drop inside the cell? You know, potential drop means basically potential across the cell or inside the small cell. IR, current and resistor. Total potential, because we said your total maximum voltage E will be equal to capital IR and small IR. Capital IR is equal to V and it is same. Correct? this. EMF is usually more when your cell is working. And using the same equation, you can calculate in the form of resistor and V and all this value. Okay, same example. V is equal to IR. So here IR, this common. V is equal to IR, you know this. We will go to another side, this, and you can calculate all the values. Understood? Should I explain this formula ki how we got this one? Ask your question, guys. Any doubt? Anvita,
No, sir.
Pratigya,
No, sir.
Varinder,
No, sir.
Chandana,
No, sir.
Jodi,
No, sir.
Sara.
No, sir.
Sara. Okay. So now you want to calculate what is the power wasted. Dissipated means kind of waste, like spent on the external resistor. External resistor or load is capital R. This is external resistor, capital R. Here potential will be VI. V is equal to IR. Okay. If you calculate power, this is the basic power formula. P is equal to VI. You did this in 10th class also. Because you know V is equal to IR. So instead of V, you can write I R into I. So what will be the value? I square R, right? If you want to convert into the V and R, then instead of I, you can write I is equal to V by R. So it will be V square by R. Okay. And here U I value is equal to capital E R plus R. We wrote the same. Okay. Capital E Y. See this. What was your current value? I is equal to capital E divided by R plus R. Using the same formula, you use the same stuff here. Any doubt, guys? Okay. Next. If power delivered is maximum, you want to calculate maximum power. In that case, capital R will be equal to small r. So overall, capital R plus R will be almost equal to 2R. If it is equal to 2R, same method. E square by 4R. Because this will also equal to small r. Na? Make sense? So what is the maximum power dissipated? E square by 4R. Understood? So this was the, what should I say? Your closed circuit. If you had doubt, let me explain you. In case of closed circuit, you need to understand you have your cell. This cell is supplying some current, and current will pass through first to this resistor. Then cell itself contain very small resistance like this. Okay. Here, example, this voltage is E. This resistance is R, and this is internal resistance of battery, small r. If you know if this is R and current passing through this I, then V will be equal to IR. Okay, potential difference. If you know this potential difference, your total EMF, total voltage, will be equal to I into R and I plus I into small r, because same current is passing through this I current. That's why here your voltage will be I small r. E I common, then your current value will be equal to this. So you got this current here. Okay. Same thing. This E is also equal to V is equal to IR plus in the closed circuit. If you want to calculate in the form of power, power is equal to V into I. It depends which form you want to use. If you are using I and R, so V is equal to IR and I is multiplied. If you want to convert I into R, so you know V remains same. I value will be equal to V by I. Sorry, V by R. V square by. So it depends what is asked. Based on that, you can do. Same thing, you have to apply one formula. V is equal to IR. And by using this, you can from anything. Just focus on one. Remaining you can calculate. By the way, you can also link with the same topic with the work energy power. Why? Because your power is equal to work done per unit time. You know this is the most basic formula. Rate of doing work is known as power. Work done per unit time. What is your work done in the form of potential? Q into V, right? From your electrostatic chapter, you know your work done or your potential energy is equal to what? Q into V potential by time. Charge by time, what is the value? See, you can still derive this. Okay, depend what is asked. If you ask for the maximum power, in case of maximum power, external resistor and internal resistor will be same. External resistor and internal resistor will be same. Okay, external resistor, internal resistor will be same. Example, I square R. I value is also equal to E by R plus R whole square into R. If capital R is equal to small r, the E square, small r means 2r square, 4r square, multiply by, this is the maximum power. Ask me guys any doubt? Any doubt?
No,
No,
sir.
sir.
Though there are many formula, but everything is a derivative from the other formula. So people who try to memorize only formula here, they can't solve this question. But if you focus ki I need to do minimum, bare minimum formula, ki I need to know power is equal to work done upon time, still you can solve by using potential chapter. Correct? So it is correlated always. So closed circuit done. Yeah. Power dissipated maximum. So what is the maximum dissipated power value? E square by 4R. And here R when R is equal to small r. Okay. If battery is charged, it means you are adding more potential. Correct? If battery is charged, then you are adding more potential. It will be equal to this. Okay. During charging. If discharging, normal formula, whatever we used. So if your battery is not charged, then capital E will be equal to V plus I small r. But if you are charging, you are adding more potential difference, more force. So this open circuit means no current. No current. If you don't have any current, your potential will be equal to your EMF. Correct? Potential across AB will be equal to your EMF. Potential across your CD is zero. Why? Current is zero. Why? What happen in case of short circuit? Short circuit means your resistance is minimum, current is maximum. Remember, whenever you see short circuit, always also consider maximum current. Always consider maximum current. Always consider maximum current. Okay, maximum current. Short circuit means maximum current. So if two terminal of cell are joined by thick conducting wire, means resistance is minimum zero. Short circuit, direct connection, maximum current. When will you have maximum current? When resistance is minimum or zero. Okay, so maximum current means short circuit. What will be the short circuit current? EMF by internal resistance only, because in this case your external resistance is zero and potential will be zero. Why? Because you know V is equal to IR. Your R value is zero, so this is also zero. This is the same thing. If you are charging the cell, okay, positive is connected with the positive, negative is connected with the negative, so your potential will increase. आओ ताया आओ. Okay, so your potential difference will be more. Okay, any doubt? Last thing is, what is this lowest voltage? Lowest voltage means voltage that you can't avoid. See this IR. This IR, you this IR is not read by the any voltmeter, any voltage measuring device voltmeter. Okay, it is not measured by any voltmeter. So what is this value? Example, if your EMF value is V plus IR, so E minus V will be equal to IR, I small r, correct? So this lost potential is the difference between EMF and voltage. Done. It's just definition. Nobody will ask question from this. Okay. Then difference between the EMF and potential difference. EMF occur in open circuit, potential difference in the closed circuit. This is the maximum value. Potential difference is less than EMF. EMF is independent of the resistance of the circuit. Why? Because you don't have any current independent of resistance, but it depends upon the resistance. How do we know? V is equal to IR. Correct. But this EMF depend upon the nature of material, nature of electrolyte, because electrolyte are deciding your EMF. It is the source of current. Correct. So if it is a source, it is cause, it is the effect. Result. Effect means result. Any doubt, guys? So EMF occur in the open circuit. Maximum value is the source of the current. That's all. Potential difference in the closed circuit depend upon the resistance, and it is the result of EMF. Got it? Result of EMF. Result of EMF. Result of EMF. Any doubt, guys? shall we continue with the grouping of cell? Ki how we did resistance in series parallel, same cell in series parallel. As simple as that. Done. How you did resistance in series parallel, same cell in the series parallel. In case of series, doesn't matter what is your EMF nature. Internal resistance will be additive. Internal resistance will be additive. Example. Here, both the cell are connected in the same manner. Both cell connected in the same manner. So you can see here EMF is added and resistance added. No issue with this. Now compare this with the another side. Here both are opposite side. If one is positive, see opposite side. Here you will have difference in the potential, but resistance is still added. That is what we were saying. It doesn't matter how you add EMF in series because both are in series. Doesn't matter how you add in the series, your resistance in both the situation will be added. Got it? Any doubt, guys? Look at this. In this case, if anode is connected to the cathode of other cell, if anode is connected with cathode of other cell, what is anode, Sarah? Anode is positive
Positive, sir.
and cathode is negative. So if you have this anode of one, see, anode of one is connected with the cathode of other, correct? So it is in the series. See here, anode of one is connected with the cathode of other. But in second situation, cathode of other is connected with the cathode with cathode. But in series, it is ulta. If you do this, what will be your total EMF? Each cell having EMF E and resistance R. Jordan, what happened in case of series? Potential. In series combination, what happened to the potential?
It, it decreases, no?
Potential added.
It is added up for all the batteries, sir, but
Yes, if it is added and if potential is V plus V and time, can we say your total potential will be NV?
yes, sir.
Done. Same thing here. Total EMF equivalent is equal to NE. N is the number of battery. We don't know number of cell. Next, Chandana, what happened to the resistance in the series?
Sir, added.
Resistance is also added. So R equivalent will be N time of the R because the resistance in the series combination are added. What will be the current? Current will be total EMF by the total resistance. Remember, you have only one load resistor. Remaining are internal resistors. So internal resistor were NR. Total resistance, if you calculate here, total resistance, if you see, will be equal to capital R outside and NR this. And what will be your current? EMF by total resistance. Understood? Any doubt, guys? What will
No,
be the
sir.
potential difference across external? V is equal to always IR, capital R. Potential difference across each cell, because you know potential difference across each cell will be N timeless. Each cell. Power dissipated I R square. This complete thing is I. And you know formula of power is equal to I square R. That's why I value is given here. Maximum power. Actually, for your maximum power, P maximum for one cell is equal to E square by 4R. And end time. We need to focus because E square by 4R was common. Yep. This combination is used when external resistor is very high. Correct? External resistor is very, very high. Only then it is used. Done. Anybody have doubt? Because parallel will be opposite to this. Ask your question. Series combination of cell. Hello guys,
Yes, sir.
can you hear me?
Yes, yes, I
Any
can
doubt
hear you.
in series combination? Because parallel combination, like it will be easy to understand if you know each and everything from this series combination. Ask your question from series. Hmm. Anybody have doubt? Go through it. Just ask your doubt because we are about to end the chapter. We covered most of the thing. I hope there is no doubt. So in this case, parallel combination, all anode are connected to one point, all cathode are connected to other point. See, this anode, I will use different color. This anode, this anode, this anode, all are connected to one point, correct? This point. And all cathode is connected to the one point, correct? So that's why we are saying it is the how the combination happen. And if you have n number of cell connected in the parallel, what will happen? Overall, your EMF overall in parallel will be same because you know in parallel combination potential is same. In parallel combination, potential is same. Correct? In parallel combination, potential is same. So this is the in parallel combination. देखा है what happened bring the to the resistance? Barinder, what happened to the resistance? In series, resistance is n time of if all have same resistance. In parallel, resistance decrease because I told you it will be the minimum value in parallel and maximum value in series, right? Okay. So this is the resistance in parallel of the internal resistance. Total current. First, you have to calculate total resistance. Total resistance will be out load is R and internal resistance is R by N. Same. Total EMF was E. Total resistance was this. Correct. Current in each cell will decrease by N time because in parallel current is different. In series, potential was different. That's why if you remember, compare with the series. In series, your potential become N time less than V. Okay. Power I square R. I square R. Correct. Maximum power. This is important. Maximum power when R both the resistance become equal. External resistance and internal resistance become equal, then it is maximum power. Interesting part is this is same for both, right? I guess even in the series it was same. Hmm. Maximum power N E square by 4R. Here N E square by 4R. Both are same. Only any doubt, guys?
No,
So
sir.
in this case, if you want to get the this type of combination, your external resistance should be minimum. In series, if you remember, in series, your external resistance should be greater than internal resistance. Here, your internal should be greater than external. Got it? Well, then this is generalized battery. Resistance will decrease R by N, and your EMF will remain same. If there are different EMF, what will happen? Total EMF you will add. No, sorry. Total EMF will remain same. So, if you want to calculate EMF in this situation, what will you do? EMF by internal resistance is the current of everything, and this is the total resistance, correct? So how do you calculate V is equal to IR na? If you want to calculate this, what will happen? This is the equivalent 1 by equivalent resistance, and I will write this V is equal to IR. This is the current value I. This is 1 by R value. So denominator of denominator will be equal. It will be like this. Trust me, this is not required, but book is giving you in case if your resistance is different, in case if your resistance is different, EMF is different, still you can calculate. हाँ मंगवाइए को नहीं थी शायद, मंगवाइए को नहीं थी शायद. एक मिनट गाइस, लेट मी गिव. मम्मी एक काम करिए कुछ. So series parallel combination done. Mixed grouping is also there. You have both series as well as parallel. This kind of question asked mostly in word, but you never know. If they want to ask difficult question, they can ask like that. In this case, what happened? In series, you have n number of cell, uh, internal resistance n number. Further, they are connected in parallel. M number. M number is parallel. So, Pratigya, in case of series, if EMF of one cell is E, what will be the EMF of all these cells in series? Pratigya. Pratigya. And E, because potential is added in series. Anvita, what will happen to the resistance if you have each resistance small r? In series, what will be the total resistance?
So we'll just
NR.
right?
NR. Because addition, simple addition.
Yeah, so yeah.
Sarah, if you take parallel, each row have this potential NE and each row have resistance NR. What will be the total potential in case of parallel? Sarah,
Sir, IR.
potential, total EMF in parallel and E only. Why? Because in parallel it remains same. Make sense? Any doubt?
No, sir.
Jordan, what will happen to the resistance in parallel? Total.
Uh, it'll add up, but 1 by R each, no?
No, in parallel it parallel total number of resistor is M. So resistance reduced by M time.
Oh, okay. Yes, yes, sir.
Correct? That's why internal resistance is NR by M and potential is equivalent this. Total current, total EMF by total resistance. Total EMF and E, total resistance R plus this. You can calculate to make sense. So this is the total current. Is it given in the next page? Let's see. Yes, it is given. Same stuff. Across load. Load means capital R. Across, um, across load, what will be the potential difference? This. Potential difference in each cell will decrease n time. And current in parallel decrease by n time. Condition for the maximum power. The simplest way to what will be the value of the maximum power? Maximum power will be equal to the maximum resistance will be equal to the internal resistance total. Here maximum resistance is R. What is the total internal resistance? NR by M. Understood? So it is this. M n time. M n time. Total number of cell M multiply by N. How? Like if you have total 5 cell in series 1, 2, 3. Let's take 3. And same way you have 5 cells, each of 3. So total, what will be the total number of cells? 15. 5 multiplied by 3. Make sense? Topic is done. You know, if two cells are connected in parallel there is same EMF and same internal resistance R. So what will be the total EMF? This will be your resistance and EMF. It will remain same because we said in case of parallel EMF remains same. Resistance in parallel will reduce. resistance in the parallel will be n time less. Got it? N time less. Same thing is given here. N time less. So majority of the chapter is done, guys. Resistance is done. Cell is done. Normal current is done. Kirchhoff law part is left out. Jordan, you sent me the syllabus, correct? Let me go through it. Guys, how is it going? Anvita, how it is going?
Fine, sir.
Fine. Pratigya, how is it going? Pratigya, are you there? Barinder, how is it going?
So good.
Okay. Next, Chandana, how is it going?
Yes, sir, it is going good.
Okay. Jordan Roland,
Yes, sir.
how is it going?
It's going good, sir.
Sarah Anthony,
Good, sir.
okay. So current done, drift velocity, mobility, Ohm's law, VI characteristic, electrical energy, power, resistivity, conductivity, series, resistor, temperature dependence, internal resistance, potential difference, EMF of this cell, combination of series and parallel. Oh wow! It means only three topics are left: Kirchhoff laws, application, Kirchhoff law basically, Wheatstone bridge and meter bridge. That's all. Kirchhoff law, Wheatstone bridge and meter bridge. All look similar. Great. Everything else is done. वाह जी वाह, वाह जी वाह. Guys, just give me 1 minute. So, in this case, Kirchhoff, Wheatstone bridge and meter bridge. First, we'll finish these three topics. Kirchhoff law. Again, same thing is given. Rate of flow of charge at any cross section is the current. And if it is uniform, this everything is same key. Serious unit is EMU or biot BI. 1 ampere is equal to this, but to be honest, not so important. You should read once. Not so important, but you should read once. 1 ampere current means this number of electron flow in 1 second. Why? Because you know I is equal to NE by T. If we are saying it is 1 N in 1 second we want to calculate. E value already we know 1.6 into 10 raised to power minus 19. Correct? So if it go to another side, 1 by 1.6 into 10 raised to power minus 19 become 10 raised to power plus 19. You can calculate the value. It will be this 6.25 into 10 raised to power 18. This is the number of electron will flow in 1 second. It means that will be 1 ampere current. And you know what is the direction of current, Jordan?
So the direction of current is opposite to direction of flow of electrons, no?
Yes, opposite to the direction of flow of electron. What is the net charge Pratigya in a current carrying conductor? Pratigya, in a current carrying conductor, what will be the net charge? Net is zero. Why? Because you know atom is neutral. Every conductor is made up of atom. Have equal number of proton and electron. Net charge is zero. Okay. Then current does not change with the change in the cross section because current does not depend upon the area. This kind of question is only important for your NEET and extremely important. They can give you direct question. Okay, these are the area I1, I2, I3. Area is changing. What will be the value of current? Current will be same because current does not depend upon this, but current density does. Because you know current density. Barinder, what is the formula of current density? Or sorry. Barinder, what is the current density? Barinder, are you there? Barinder, Pratigya, both have. Jordan, you are there?
Yes,
Yeah. So current will not change, but current density will. Why? Because current density depend upon area. Here area is changing. When you change area, current density will change, but current will remain same. Then current in the translatory motion. Anvita, what is the meaning of translatory motion? Anvita, what is translatory motion? No,
So,
no, you are. Barinder is facing network issue. Chandana is not there. Pratigya, no.
हाँ सर
अरे तुम जिंदा हो?
हाँ
कम से कम 2 दिन से मैं तुम्हें कॉल कर रहा हूँ, बुला रहा हूँ मतलब मीटिंग में कि प्रतिज्ञा आर यू देयर, प्रतिज्ञा दिस क्वेश्चन. नेटवर्क इशू हो रहा है क्या?
हाँ सर फोन हैंग हो रहा है
फोन हैंग हो रहा है? ठीक है, तो मूव टू द नेक्स्ट. तो हाँ अनविता, ट्रांसलेटरी मोशन. Motion in straight line. Motion in straight line is known as translatory motion. If any charged particle are moving through a given area in given unit of time, you know it is equal to NEA VD. Correct? NEA VD. So you can calculate current. NEA VD, same thing as here. NEA VD. Okay. But remember, this N is number of particle per unit volume. Number of particle per unit volume. Okay. Pratigya, in case of rotation motion, current is equal to charge upon time. 1 by time is equal to frequency. 1 by time is equal to frequency. Or you know, velocity in the rotation motion is equal to 2 pi r length by time. So can you say that time will be equal to 2 pi r by velocity? That's what we wrote. 2 pi r by velocity. Charge remains same. This charge is equal to this charge. Okay. Correct. And you know V is equal to R omega. Correct. So V is equal to R omega. Instead of this V, if you write R omega Q V by 2 pi R was there. If you write R omega 2 pi R, what will happen? R cancel this. Understood? I have seen this question ki you have to consider rotation motion while you are reading about the current. Right? You know this. Sometime you have to do integration if you are calculating total charge. IDT, you know the method, but more importantly, sometime in case of current, if you want to calculate, you need to do integration. Okay, you need sometime differentiation also because it could be dq by dt. With respect to time, you have to do differentiation. Okay, you have to do differentiation. If you take slope of q and t and you want to calculate instantaneous current, basically what you need to do? Differentiation. For instantaneous current, you need to do differentiation because it is the graph between t and q. Remember, whenever you want to calculate, what you need to do, Chandana? How, like, who face the minimum problem among you? I think Anvita or Jordan.
Problems as in, sir?
Like Zoom kick you out and then there is an issue.
I face sometimes here because network's not so strong in my uncle's house.
Anvita, you don't face much problem.
No.
Okay. Probably because you are staying at one place, so your network is stable.
Yeah, maybe. Yeah.
Chandana, do you travel sometime and face network issue?
Yes, sir.
Okay, because even it happened with me, but like hardly once in a day or like even less than that. Next. So slope between the charge and time will give you like current, instantaneous current. Area under I and T will give you charge. Why? Because your dq will be integration of this. Imagine ki in the same thing you have to do different, you have to use different method, whether differentiation or integration. It depends what is given. In first situation, charge and time will give you current. Second case, current and time will give you charge. Jordan, you face problem in this Kirchhoff law.
Yes,
Most easiest topic ever you will see. Here, it is saying Kirchhoff first law is also known as junction law. Why? We want to study what happened at the junction. If you have multiple wire and there is one junction between the wire, what happened at the junction? This is also known as current law. Why? Because at this junction we study current and we say total current at the junction in a closed circuit is zero. It means total amount of current enter into it is equal to total amount of current exit into it. You see, I1 is the current that enter into the wire. I2 and I3 is the current that exits the wire. So entry is equal to exit, total current same. Jordan, tell me, is it difficult?
no, sir.
Total current at a circuit is zero. It means total amount of current entering into it is equal to total amount of
It
current.
is equal to total going out of it.
Yes. It's same like at a junction of the traffic junction. what is the net number of vehicle will stay? 0, because total number of vehicle enter into the junction will be equal to the total number of vehicle exit from the junction. Make sense? Net current 0. Correct? Any doubt? Then example, if you see I3 is entering, I3 is entering, I4 is entering, I1, I2 and I5 is exiting from this. So you will say in this situation I3 plus I4 will be equal to I1 plus I2 plus I5. Okay. And if it is taking this now, it only means is you can take this. I3 is entering and I5 is also entering. So entry is equal to exit. Entry is by 3 and 5 and 1, 2, 4 exit. Understood? So there is a diagram mistake. Total current enter into the junction will be the total current get away from the junction. And same thing is happening here. Current cannot be stored at junction because it does not act as source or sink. It does not produce charge or it does not absorb the charge. And because total current remains same, it is the law of conservation of charge. Mr. Jordan Rowland, is it difficult?
It's, it's fine, sir, but then application in the circuit is where I usually face issue.
Total current entry is equal to total current exit. Done.
Yes, sir.
Second law is also known as loop law or voltage law because in this case we use voltage. Why loop law? It always act in a closed loop. It is applicable in a closed loop. Okay. So like how in a at a junction net current was 0, same in a loop net voltage is 0. There is no change in voltage in a closed loop. That's all. Okay. Understood? Done. So total current 0, first law. Total voltage 0, second law. Current 0 at junction, voltage 0 at loop. And you know your voltage is related to energy because your energy is equal to Q into V. Correct? If your voltage is not changing, then your energy will remain same. Make sense? In a closed path, net energy will remain same. So it will follow law of conservation of energy. So force will be conservative force. Work done in any closed path remains 0. And you know this. Work done in a closed path is 0. Work done in a closed path is 0. In this case, you have to be very careful about the closed path. In total potential in a closed path will be 0. As simple as that. आओ भाई साहब आओ. हाँ. Okay. So what is the difference between the first law, second law? This is for charge, this is for energy. Here total current is 0, the total potential 0. Difference in potential. It is applicable for both open and closed circuit, only for the closed circuit. Done. Do we have galvanometer in this topic? Kirchoff and its application, wheatstone bridge and meter bridge. Galvanometer we have in other topic, I guess. Jordan, I think we have
Yes,
galvanometer
sir, we
in
have galvanometer.
but not in this chapter.
No, sir.
Okay. But we
I
will study
think
here.
towards, yes, sir. I think it's involved during LCR circuits and all, because I remember some questions having it.
I guess it is in magnetic field at the end of magnetic field.
There also it's there, yeah.
So we'll do here. Galvanometer, an instrument that detect very small current. Okay. How? Deflection. You must have seen galvanometer in the real life. Even in the motor at your terrace must be having this. See this. Like if you connect with the wire, then it will show deflection. This is the simplest version. It will show deflection on both sides, positive and negative side. So this is the internal structure of the galvanometer, like how it will move based on the current supply to it. Correct? And you must have seen this. Correct? Almost whatever you do, you will use galvanometer almost in every device. Okay. Moving coil I think yeah, moving coil galvanometer you have in your syllabus. Moving a magnet galvanometer you don't have. Hot wire is consider your syllabus part. And in moving coil galvanometer that we have in syllabus, we use DC, not AC. Because for AC we have entirely different chapter. DC, this one. Okay. Symbol of galvanometer G. Because G means resistance. Galvanometer measure current, detect current. But galvanometer G itself is the symbol of the resistance. Okay. Total internal resistance in the galvanometer. Because it is inbuilt. Full scale deflection current. How much current is required for the complete deflection of the galvanometer? Complete deflection. Ig means through galvanometer current amount. What is the shunt? Small resistance in parallel. See, S is shunt and it is parallel to the galvanometer. Correct? Why? Because if you have resistance in parallel, then you know parallel resistance, equivalent resistance will be very, very less. If resistance is less, then you can measure more current. Okay, that's why when you will use this same galvanometer for ammeter to measure the current, what will you do? You will use this galvanometer in the like this shunt in the parallel. Why shunt in parallel? Because shunt in parallel reduce resistance, increase current, and we want to measure current. That's why we want maximum current. Okay, so remember, shunt is always connected in parallel. It is used in ammeter, measuring the current. Here current is increased because resistance will be less. Any doubt, guys? Benefit: protect the galvanometer from burning. Demerit: decrease the sensitivity of galvanometer. Look at this. Ammeter measure current always in the series of your load. Series of your load. Series of your load. Reading of ammeter always less than actual because some will be taken by the system. Small resistance of ammeter is more accurate in its reading. So ammeter should be idle when resistance is minimum. Internal resistance. Why? Less resistance, more current. More current, more accurate. Correct. That's why if you want to make ammeter, you need minimum resistance. Why minimum resistance? When resistance is minimum, then current is maximum, and it is good thing. You want to measure current, you want maximum current. How to get minimum resistance? By connecting shunt with the parallel. By connecting shunt with the parallel. So if you take shunt of the low resistance and that too in parallel. So example, this galvanometer resistance is let's take 500 ohm. This resistance is zero point 0.2 ohm. Your overall resistance, overall R will be less than zero point 0.2. It's good. You want minimum resistance. That's why you are using in parallel. Ask me, guys. Any doubt?
No, sir.
Anybody? Chandana?
No.
Sarah?
No.
Marinder? Marinder is not there. Pratigya?
No, sir.
Next, Miss Mathur.
No doubt.
Huh. Okay, so if we calculate the total resistance in this case, you know both are in parallel. That's why it is like this. G into S, G plus S. Why? Example, if you want to calculate total resistance, equivalent resistance, what will happen? 1 by R1, let's take this G. 1 by R2, let's take this S. So 1 by R equivalent, GS LCM, G plus S. Cross multiply, this R equivalent will be equal to this. Make sense, guys? इतनी थोड़ी उठेगी तो okay. In this case, both are in parallel. You know, potential of this will be equal to potential of this. Both potential will be same. So potential of first is IgG. Potential of second is IgG into S. Makes sense, guys? Because total potential across G will be equal to total potential across S. Understood? If you know this, you can calculate S value. What is the shunt value? How? Because Ig, this I minus Ig will go to other side. Correct? I minus Ig will go to other side. Any doubt, guys? This is very important because we use it very frequently and your ammeter is done. Done. Is it done for everyone? Because voltmeter is comparable. That's why every time I ask you about first topic, because second topic will be in parallel and you will understand actually more. Okay, ammeter. If you have another part of current, you know, in case of parallel, current will reduce. In case of parallel, current will reduce. भाई साहब एक तो मैं लाइट वाला भी कर दोगे जो मैं लाइट रही डाउन सीलिंग में वो करना चाहता हूं क्या कर लो आज जो है ये सारी कराऊंगा अच्छा सेम लग गया ठीक है ये तो बाथरूम में बन गया इसको ऊपर को नहीं आपको मैंने टाइम बना चाहिए सारी करते हैं ठीक है पूरा एक बल्ब और लाना पड़ेगा कोई नहीं ठीक है okay guys any doubt because your current I is reducing and what was your S value Ig through galvanometer I minus Ig G correct if your Ig value is I divided by N here I remains same this is I divided by N I will be LCM common outside G so you can calculate this value and it will be this ask me your doubt Yes or no, guys? Is this correct? Are we getting the same answer? 1 by n. It will be n minus 1 by n. G n answer. Yes. Sorry. Any doubt? It's just you kept in the value of Ig as I by n because you will get only those numerical. The nth part of main current, 50th part of main current, 25th part of main current. These are very common numbers. Voltmeter is connected in the parallel to the current element. Ammeter series. Ammeter series to the system. Voltmeter parallel to the system. Voltmeter are present parallel to the system. इतनी थोड़ी ऊपर आगे दो. Okay. So if you see the reading of this voltmeter, it will be lesser than the true value. Same like current. Why? Because some amount will be always wasted. Because you want to calculate potential, and potential is made up of I into R. In this case, if you increase R value, your voltage value will be more. If you increase R value, your voltage value will be more. If your voltage value will be more, then it will be better. For ammeter, you want maximum current. For voltmeter, you want maximum resistance. More resistance, more voltage. Good. Okay. So voltmeter will be ideal if you have maximum resistance and minimum current. How to do this? First, it is parallel to the system. Parallel to the system. But your um, resistance is present in series with the galvanometer. Example, if you see here, so in this case, what is happening in ammeter? S is parallel to G, shunt is parallel to G because you want to reduce the resistance. But in voltmeter, you want to increase resistance. How to increase resistance? By by adding in the series with G. That's why it is present in the series with G. Understood, guys? Yes or no?
Yes,
In
sir.
series, you know, voltage are different, but current is same. So if you have this current in the series and this is the voltage will be different in both, but current will be same. So total resistance G plus R because series. Total voltage, current is this is resistance. By using this, you can calculate R value, how much resistance you need to add. If you apply nth part in this case, you know in series your potential decrease, in parallel your current decrease. Understood? And we are applying the same. Guys, is it going too much or like you are able to understand each and every stuff?
No, sir.
Like, is it too much or you are able to understand it?
Not
Sarah,
able to understand everything.
It's a bit too much. So
Jordan, it is.
Yes, so
Sarah, you
much.
are able to understand everything.
No, sir. No, no.
You are not like you don't have doubt or you are not able to understand everything.
Not able to understand, sir.
You are able to understand.
I'm not able to.
Oh, is it going too much?
Yeah.
Sir, I'm not
Okay.
able to find.
so I'm
Chandra, you are not able
understanding
to.
but not catching up.
Okay, Jordan. Chandra, what you said? You are not able to.
Right, but I'm understanding little bit.
Okay, like it's okay if you are not able to write completely, but you understood everything, right?
It's a little bit.
Okay.
So could you
Pratigya?
do like a summary part once more after that?
Yeah, sure. I'll do summary of everything. If you see ki it is going difficult, then I'll do summary of every topic one by one. Example, galvanometer, complete galvanometer I'll do. Pratigya, is it okay for you?
Yes.
Tanvita?
So I'm understanding enough forgetting the previous thing. So
Okay. So I'll do revision. Oh, this is already done. So Jordan and Sarah, you had issue only in this galvanometer, right?
That and for me, meter bridge also, sir.
Which one?
Meter bridge.
We didn't do meter bridge.
We didn't have, okay. I thought you were asking from the whole chapter.
No. Whatever we did, you have issue in the galvanometer.
No, sir.
Okay. Sarah, you have issue in galvanometer.
Yes.
Okay. So in galvanometer, what happened? It measure current, small current. Whenever there will be current, it will deflect. Okay. So basically, galvanometer symbol is expressed in the form of G, and this G is actually a kind of resistance. This is kind of internal resistance. Okay. Now this galvanometer can be converted into two form: ammeter to measure current and voltmeter to measure voltage. You need to understand that whenever we measure current, when we measure current, we need maximum current, and for maximum current, you need minimum resistance. And Sarah, if you need minimum resistance, how you want to attach resistance? Series or parallel?
Parallel.
Parallel. So you will attach in the parallel. And here, this resistance with the minimum value that is attached in the parallel is known as shunt, with R value less, very less. Okay. Voltmeter. In voltmeter, we want to calculate voltage. So voltage should be more. If you want more voltage, then what should be your resistance value, less or more? Sir, because in series, current
Uh,
remains same. Resistance should be
more.
more. And how you get more resistance in series or parallel?
Series.
Series. You need high resistance or low resistance.
High resistance.
Done. So you understood if you have galvanometer G, then you will attach a R value that have very high value of R in case of series. Correct? If you are using it for the ammeter, you have this galvanometer G, and then it is this shunt in parallel, and this value here R value, resistance value will be less. Any doubt, Sarah?
No, sir.
In this case, if let's take this current is I and current going to galvanometer is Ig, then remaining current in this will be I minus Ig. And in parallel, potential remains same. So potential through S will be equal to potential through G. Potential through S, I into R. Current value is I minus Ig. And resistance value is equal to S. In G, current value is Ig and resistance value is G. Okay. In parallel, whenever you calculate total current for n number of parts, if you divide into n number of parts, then current value will be I by n. We did this in the cell also. Here it is in series. So current will remain same. If it is Ig, this will also be Ig. Correct? Okay. So current will be same. So if current is same, it means their potential will be different. Example, potential through this is Vg. If you have total potential supply as V, then it will be Vg, then this will be V minus Vg. Correct, Sarah? Any doubt? Because potential in series is different. Current remains same. Okay. It means if Ig in both the situation is same, so you know I is equal to V by R. So it will be Vg by G equal to V minus Vg by R. Understood? Because current is same in this situation. Here resistance is same. Done. Galvanometer is done. Any doubts, Sarah?
No, sir.
Anybody have doubt in this? Now look easy. Comparison.
Yes.
Don't hesitate if you feel ki sir, this is going too much. Because this stuff, na, this rated part, sensitive potentiometer, heating effect of current, we will not do now because it will be too much. Potentiometer you don't have, I think now. You have only meter bridge and wheatstone bridge. Wheatstone bridge is the application of your Kirchhoff second law. This wheatstone bridge say that if you have different type of resistor, four resistor, and they are present in the form of bridge, if galvanometer show no deflection, it means current through galvanometer is zero. That's why it is not showing any deflection. Okay, that's why galvanometer is not showing deflection. So you will call this bridge as balance bridge. So balance bridge is the bridge that show no deflection. It's like if you have one wall this side, another wall this side, and you are making bridge against it, then you know if this bridge is balanced, it will not move. It will be stable. Same way, if Wheatstone bridge is balanced, then there will be no deflection in current. Understood? Easy as of now. नहीं बढ़ गया भाई साहब. Okay. So in balance situation, current is zero. Then the ratio of resistance P by R will be equal to Q by S. Okay. I said P by R will be equal to Q by S. You can do ulta also, cross multiply. P by Q is equal to R by S is still correct. Here you will apply Kirchhoff second law, voltage law or loop law. Got it, Jordan? Example here. If you, how should I take? If you take this, you take current I1, pass through resistance P, then current Ig and resistance G, and then here current I minus Ig, I minus Ig, and here resistance is R. This is a one closed loop. Now you are starting your journey from A point. You are starting your journey from A point. What will be the voltage between A to B? Understood? What will be the voltage from B to D? Okay. And voltage from D to A. Understood, guys? But this value will be negative. Why? You are moving from D to A. You are moving from D to A, and arrow of the current is opposite. Okay. Arrow of current is from A to D, but you are moving from D to A. That's why you have to take negative. Jordan, any doubt? Here,
No,
current
sir.
direction is I1 direction is this side, and you are moving in the same direction. That's why positive. This is also you are moving from B to D, so positive. But when you are moving D to A, but your current is opposite, that's why you took negative. Anybody have doubt? And now look at this equation. I1P plus I1G plus, but I minus I1R is negative. Understood? And total value is zero. Reason? Kirchhoff's second law, loop law. Jordan, you are facing issue in this only, no?
Yes, sir.
Same thing you can apply. It's your choice how you want to move. Always it's your choice. Imagine, I will rub this again. Guys, try to understand such topic more than writing. It does not mean you are not supposed to write, but first you need to understand. Otherwise, you will not get it. Here, total current was I. If this current is I1, what will be this current? I minus I1. Just like if it is 10 and this is 2, what it will be? 10 minus 2 or 8. Same thing. Correct? Then from I1, some current will go Ig. What will be this current? I1, I1 minus Ig. Right? I1 minus Ig. Here, this current is fused. I1 minus Ig was this current plus Ig. So it is moving like this. Then they will fuse together. And once they fuse together, it will again become I. Addition of all these things will be I. Any doubt, guys? So now it's your choice how you want to move. Example, you are moving from B to C. You are moving from B to C. What will be your current? I1 minus Ig. What will be your resistance? Q. Then you are moving C to D. You are moving from C to D and current is opposite side. That's why it will be minus I minus I1 plus Ig into S. Okay. C to D because current direction, your direction is opposite. Then D to B, you are moving up, but current is moving down. So minus IG G. Tell me, guys, any doubt? Anvita,
No, sir.
Pratigya,
No.
Barinder, सर मैं तो अभी आई हूँ.
Yes, sir.
संजना,
No, sir.
पूरा बोलना चाहिए कुर्सी पूरा ना बैठ जियो. हाँ. अरे 5 लाख रुपए 5 5 10 हाँ 15 15 15
मेरे बाबू मेरे ताऊ गए छोरी होले देख मैंने मन ना लेट ना
तीनों प्रस्थान करो जल्दी.
ला करिए एक बार ये सोल्व ठीक है उर्ली साजा फिजिक्स
Chandana, any doubt?
No, sir.
Jordan, Mr. Roland,
No doubt, sir. I got it.
Sarah.
No, sir.
So we are applying Kirchhoff rule. What is the rule? You go in a direction. If current is present in same direction, positive. Current in opposite direction, negative. Done. Total addition will be 0. Right? If your movement current is same direction as your direction, then value will be positive. If opposite direction, then it will be negative. Then if you apply both the rule and take this, you have to understand this. Ki galvanometer show no deflection means Ig value is 0. In this case, bridge is balanced. Okay. If bridge is balanced, you will take this situation and you know. Okay. So wheatstone bridge where AB and BC have PQ form the ratio arm. AD and R have variable resistance arm and DC have unknown arm. S is unknown. Look at here. S is unknown. Q is changing. PR is fixed. You can calculate total value. No problem. Okay. So it does not matter. It's just there are different name given, but never question asked from this. Done. Okay. This ratio. If it is balanced, potential at B will be same as potential at D. Potential at B will be equal to potential at D. If both potential is same, Anvita, what will be the potential difference in this situation? 0, because both are same. Difference is 0. If difference is 0, then your current will be 0, right? If potential difference between them is 0, then current is 0. So we are saying if you want your galvanometer to be balanced, your potential at B should be equal to your potential at D. Potential at B should be equal to potential at D. BD should be equal. If it is unbalanced, what will happen? Value will change. Value will change. Example, if current is going from B to D, sorry, D to B, when is going from D to B means lower to up. I have to make it big, yeah. Low to up, D to B, upward direction. What will happen? Then lower potential will be more. Okay. And your P and S multiplication will be more. Don't get too much into it. Leave it. This is not required. Application you use in the meter bridge that you have in the syllabus, post office box, and force carry poster bridge, where you want to measure the unknown resistance. Example, in the meter bridge, here you want to calculate unknown resistance value. So you can calculate by using the wheatstone bridge. Okay, you want to calculate one value, you can calculate by using this. And this is the next step. Tell me, guys, understood wheatstone bridge? A bridge which is balanced when current is 0. And if current is 0, the ratio of resistance will be equal. P by Q is equal to R by S. Done. That's all. Why we prove that Wheatstone bridge? Because I wanted to show you in numerical how you will do application of Kirchhoff's second law. For your NEET, you don't need this derivation, but you need derivation how to apply Kirchhoff's second law. Wheatstone bridge, you don't get many questions. Easy, like straightforward ratio. And if you remember, you have same thing in electrochemistry also. Do you remember, Chandana? In electrochemistry, you have the same wheatstone bridge.
Sir, in electrochemistry.
Yes,
Yes, so it's the
Yeah, sir.
it's there. It's there in electrochemistry. So almost application of wheatstone bridge, you will just keep a different value and you will get meter bridge. Everything is same. It's just you have to read one more thing. I think this will be the last topic, guys. Wheatstone bridge done, Kirchhoff law done, application done, meter bridge is the last topic. Wow. Finally. So after finishing this chapter, I will give you break. I think all of you need break. No, 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 no. You don't need break. You are very attentive right now. Right, guys? You don't need break now.
We need, sir.
yes, sir.
Everyone.
Yes.
Okay.
So
No,
when will you take?
actually, I will give. Uh, I will. Wow. Okay. How much time do you need? 7 or 6:30?
2 hours.
बहुत ब्रेक मांगता है प्रतिज्ञा तुमको. Okay. So I'll take at 5. Oh, sorry. 7. Last topic of this chapter. Slide wire bridge or meter bridge. It is the application of whetstone bridge. It have a wire that made up of material, constant N or manganese. These are the material name. Length of the wire is 1 meter and area is uniform. Okay. A meter is fit on the wooden board. You have a meter scale along with that's why meter bridge. A bridge that have meter scale in it. Okay. Copper strip is also fit on the wood block. Why? To provide two gap in the strip. In one gap, you will have R resistance, which is known, and another gap you have S resistance, which is not known. Okay. Positive pole is connected with the terminal A. See A with the positive side. Okay. And C is connected with the another side. K key. Okay. So it look like your proper Wheatstone bridge. How do we know? Because if you look at this diagram, this part I will make it big. From A to B. From A to B, what will happen? A to B, you have P value. It is like your resistance P of length L. Q is like your resistance Q. Total length of a 1 meter is 100 centimeter, 100 centimeter, 100 minus L. Because total length is 100. From A to C, total length is 100 centimeter. If one is L, another will be 100 minus L. This is known and this is unknown. This is unknown. So you want to know the value of this. Okay. In this case, we will change. This is jockey. Wherever you have galvanometer, na, galvanometer is connected with the end. This is jockey. Okay. So we adjust the position of jockey on the wire at B. It's your our choice. We can keep on changing. It's our choice, 100%. And we want to check the point where galvanometer show no deflection. And in the wheatstone bridge, if galvanometer show no deflection, then ratio of the resistance will be same. Then ratio of the AB and BC wire, you can take P by Q is equal to R by S. P by Q will be equal to R by S. Correct? So if P have length L, then it will be L into R. And if Q have resistance for the wire this, it will be in this form. You can take their ratio, RS value we don't know, and you will come up with the unknown resistance value. Done. Simply, instead of P, you have like L. Instead of Q, you have 100 minus L. This is R by S. You want to calculate S value, done. 100% Wheatstone bridge application. Nothing else. Tell me, guys, was this easy? Say yes, 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 yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
And I think this whole thing we did potentiometer, we should do the same stuff. Major EMF more accurately. Heating effect of current. You won't be able to bear this pain of this topic, right? Can you?
No, sir.
No? Should we stop here?
Yes, sir, we can take a break now. My head is cluttered.
Your head is cluttered.
Yes, sir.
Same, sir.
Yeah. Okay, then, guys. See you then at 7. Take rest, proper rest. Because, and once you take a rest, remember, revise your this chapter properly. I already sent PDF in the group. 1 hour you can take proper rest without focusing too much on this. Okay. So 1 hour proper rest, 1 hour revised. Like 1 hour, it's your choice. 10 minutes, 15 minutes, 1 hour, but revise this properly. Okay. See you guys at 7.
Thank you, sir.
Till then, take break. We'll solve questions from this chapter, and then we'll
So
do
the
12.
doubts for
Doubt we'll
coordination
discuss today.
compounds. Okay, sir.
So, will we do chemistry or physics at 7?
Physics question and then chemistry.
Okay.
At least half an hour, minimum 15-20 question from this. So how much portion is left? We did 2 chapter, 3 chapter. Wow. One optics, magnetic effect part, 2 major part. Okay. We can easily do this. Okay. Bye guys. See
Thank
you.
you, sir.
Thank you.
Okay.
Bye.
Okay.